Okay. Now what is the issue with DMVPN phase 1? Yes, all the spoke sites are going to communicate via headquarter, via hub router. And whenever we will add the spoke routers, new branch offices, we have to configure hub router. So that's why we, yeah, hub to, yeah, here tunnel will be active. Okay. And the new configuration, if we are going to add the new branch office, new sites, then every time we have to perform configuration on hub router. So to overcome these issues, we come up with DMVPN phase 2. DMVPN phase 2, right? Let me discuss DMVPN phase 2 first. After that, I will show you the issue with DMVPN phase 2, right? So, like why we come up with phase 3. So total we need to learn 3 phases. Phase 1, phase 2, phase 3. First of all, let me configure phase 1 here. Let's begin the configuration from R1. Before that, let me verify the public IP reachability like 2.2.2.1. You can see I am not able to ping a spoke 1 public IP address. Let me troubleshoot it. I think default route is not there. So IP route, yes, default route is not there. Let me configure the default route. IP route 0.0.0, 0.0.0, and next hop IP is 1.1.2. Then on router number 2 also IP route 0.0.0, 0.0.0, and 2.2.2.2, and then finally on R3, which is my spoke 2, IP route 0.0.0, 0.0.0, and 3.3.3.2. Now let me ping again, and now you can see ping is working. I am able to ping the public IP address of spoke 1 and ping 3.3.3.1. I'm able to ping spoke 2 as well. Now let me create the tunnel here. Interface tunnel 1, IP address 192.168.10.1, 255.255.255.0. Then tunnel source fast ethernet 0/0, tunnel mode GRE, multi-point, and IP NHRP network ID 1. Then guys, IP NHRP, yeah, we can configure the authentication. Let's say Cisco 123. Then anything else? This is the configuration. Anything else? Mapping which command? IP NHRP map multicast. So if I'm running multicast, then I have to configure what? NHS IP address on all the spoke sites. Leave it for now. Before that, let me do the basic configuration on spoke 2 and spoke 3. Here I am going to create tunnel IP address 192.168.10.2, 255.255.255.0, tunnel source fast ethernet 0/0, and then tunnel destination 1.1.1.1, IP NHRP network ID 1, IP NHRP authentication Cisco 123, and IP NHRP NHS. NHS IP address will be what? The public IP address or the tunnel IP address? NVMe address or the tunnel IP address, guys? Hmm? Tunnel? NVMe. So if I will say 1.1.1.1, or if I will say, let's say 192.168.1.10.1, right? So router 2 need what? NVMe address of this IP address. Then only it can forward traffic. Then only it can send the traffic. Right. Mapping is required. Here, guys, we will define the tunnel interface IP address, not NVMe address. Done. So we need to run one more command here. I have to configure the NVMe address of this IP address. So IP NHRP map 192.168.c destination IP address 192.168.10.1 and then NVMe address 1.1.1.1 on order number 1. So IP NHRP. Is there any mapping? Yes. The remote tunnel IP address and their NVMe address. How router 1 have got this information? With the help of NHRP registration message. With the help of NHRP registration message. Once you will configure NHS IP address here on order number 2, this IP, it will send one registration message. I am removing these two commands for now. For a minute, let me say no to this and no to this also. And then go to router number 1 and NHRP clear IP NHRP and so IP NHRP. Is there any entry? Now, no. Now guys, see on order number 2, if I am seeing your NHS is 192.168.10.1. Is there any entry? No. What is the issue? This is the troubleshooting. What is the issue? Sorry, here I am going to define the NHS IP address. NHS IP address 192.168.10.1. Now, how router 2 have information about the NVMe address? Sorry, bro. Clear IP NHRP. I'm asking you this question, like I have defined the NHS IP address, but to send traffic to this IP address, router 2 need what? NVMe address. How it have got the NVMe address? You have defined it, right? The tunnel destination IP here. So on actually a spoke router, we are defining the tunnel destination. So this command is not required here. This mapping. Where mapping is required, where destination NVMe address is unknown, where the remote NVMe address is unknown. Getting my point? Always keep in mind like this: if I am defining IP address, or if this router need to forward traffic to 192.168.10.1, router need NBMA address whenever the exit interface is tunnel interface, right? Like here, if I am running one route, IP route, let's say 50.1.1.0 and 255.0.0.0, and exit interface is tunnel 1 interface. What happened? Bad subnet mask. IP route 50.1.1.0 255. This is correct. What happened here? Do so IP interface brief. The interface is up here. IP route 50.1.1.0 255 255 255.0, and the exit interface is tunnel 1 interface. Done. So I have configured one static route here. See, if I am pinging, do ping 50.1.1.1, it will check the routing table. It will compare destination IP address with their routing table, right? And in the routing table, guys, it will find the exit interface is tunnel interface. So IP route, it will find exit interface is tunnel interface. So whenever exit interface is tunnel interface, that time router need what? NBMA address. Router need NBMA address. And if the GRE mode is point to point, then you are going to configure what? Tunnel destination, and tunnel destination is nothing but the NBMA address. For now I am going to remove this route. So IP NHRP, so run interface tunnel 1. This is the spoke configuration in DMVPN phase 1. And so IP NHRP, again we don't have any mapping here. There is no mapping, right? But guys, once I will ping to R1, ping 192.168.10.1, even ping is not working. Type is incomplete. So router 2 is not sending the registration message. So run interface tunnel 1, tunnel destination IP NHS tunnel source Cisco 123, IP is fine. Interface tunnel 1 and IP NHS NHRP NHS 192.168.10.1. Done. Now again I can ping 192.168.10.1. See, ping is working. This is phase 1 configuration. Here we have one more command, so DMVPN. So you can see the peer. This is NBMA. This one is the, so you can see the sequence number. This is NBMA address of peer, and this is the tunnel IP address of peer. The state is up, and this is the time till when the peer is up. In the same way, let me configure phase 1 on R3 also. Interface tunnel one IP address 192.168.10.3 tunnel source fast Ethernet 0/0 tunnel destination 1.1.1.1 IP NHRP network ID 1 and IP NHRP authentication Cisco 123, then IP NHRP NHS. If you will not define NHS, then it will not register to hub router, right? And router 1 hub router will not have the NBMA address, right? See, hub router have only NBMA address of spoke 1 192.168.10.2. So on R3 NHS IP address 10.1.1. Sorry, 192.168.10.1. It will send the registration message. And now you can see hub router have NBMA address of both the site, both the spoke. Like this, in real time you will have lots of branch offices, and for all you will have what? NBMA address on the hub router. So DMVPN, you can see now we have two peers, and I can ping to side 1 192.168.10.2 and 10.3. So this is what my overlay network. And guys, inside the in the underlay network we will have lots of path between, like hub and spoke 1 you can have 50 number of path, you can have 60 number of path, and your VPN, your tunnel is one path, one virtual connection over the physical connection. That is the best path, as I told you, because inside the ISP, inside the service provider, there will be lots of routers. So you have created the virtual network over service provider network. And if these two IP addresses are reachable with each other, then you can configure the routing protocol or anything. If the IP address on this interface and this interface are reachable, then we can form any neighborship. We can exchange many things. Done. So let me do one thing now. Now I need to advertise LAN networks in LAN networks to remote sites. Like on hub I am running 10 submit 10.1.1.0/24. Let me do one thing. Let me configure a static route here, IP route, and spoke 120.1.1.0 255.255.255.0. What will be next hop IP address? What will be next hop IP address for this network? Hello, am I audible, guys? Yeah, which tunnel IP address? Yeah, I spoke 192.168.10.1. I'm getting error. 10.2. Correct. And I need to configure one more route, that is 30.1.1.0, and for this next hop will be 10.3. On R2 IP route 10.1.1.0 255.255.255.0, and next hop 10.1. Then one more subnet 30. And what will be the next hop for 30? .1 or .3? .1. right? Because guys, we don't have tunnel with this IP address with 10.3. So 10.1, spoke 1. Now on spoke 2, IP route 10.1.1.0, 255.255.255.0, 192.168.10.1 and 420 as well. Now we can verify the connectivity ping 192.168.10. Sorry, 10.1.1.1 and source I am saying 20.1.1.1. So these two sites are able to communicate with each other, right? Now let me ping 30 spoke 2 and see this ping is also working, means all sites are able to communicate with each other. Trace route 30.1.1.1, source 20.1.1.1 and numeric. Traffic is going via hub router R1, right? Every time. This is first issue with phase 1. And now if I am adding one new site here, let's say my company is planning one new site R4. So definitely I have to configure this router as well as I have to configure hub router. What extra command I need to apply on hub router, guys? Hello? What extra command I need to apply over here? On router number 1, so run interface tunnel 1. Where is the mapping command? I am not running any mapping command here. No command is required with a static route. If I am having dynamic routing protocol, then mapping is required, like to map multicast address into unicast. Done. Now guys, in phase 2 what we will do? In phase 2 we will form tunnel between spoke 1 and spoke 2. Here we are going to form tunnel, not GRE tunnel. We'll change the mode. We'll change the mode of these two tunnel interfaces. We'll configure mode multi-point here, right? Any question guys in phase 1? Anybody have any question in phase 1? See, like if a router 1 is going to send any multicast packet to router 2 or to router 3, right? Multicast packet. So destination will be multicast address 224.0.0.10. So R1 need what? NBMA address of this multicast address, correct? Then only it can forward to a spoke router. So we have to add one more command. We have to say map all multicast address into 2.2.2.1 and 3.3.3.1. For all the spokes, I have to run IP address. So this command will map all the multicast packet into, it will convert actually multicast into this unicast and this unicast. Any other question? Okay, let's configure the phase 2. R1. So run interface tunnel 1. Spoke 1. Interface tunnel 1. Guys, I am saying uh, tunnel mode GRE multi-point. What error I am getting? Tunnel set mode failed. The reason? Point to multi-point tunnel can't have the tunnel destination IP address. So first of all, I have to say no tunnel destination. And now I can run this command. Done. Do so run interface tunnel 1. See the difference on the spoke side in terms of configuration between phase 1 and phase 2. NHRP configuration is same. Simply I have removed the tunnel destination and I have changed the mode. We'll do same thing on spoke 2 also. Interface tunnel 1 say no no tunnel destination and tunnel mode GRE multi-point. Route is still there. We have already configured the static route. Now let me show you the R1. So IP NHRP clear IP NHRP so DM VPN on a spoke router so IP NHRP so run interface tunnel 1. So NHS is already there. Let me down the tunnel interface and let me up it, shut down and then no shut. What will happen? It will send registration message again. Now on R1 so NHRP nothing is there. Tunnel mode multi-point tunnel source NHS IP address NHRP so run interface tunnel 1. Now anyone have idea guys what is happening here? What is the issue? Why there is no padding? No idea? Mapping. Now See, spoke 1. On spoke 1, we didn't configure the tunnel destination, right? This time. So spoke routers don't have NBMA address. Even hub router don't have NBMA address. So what we need? We need mapping now. We need mapping. Yeah, NHS. NHS, I have already configured the NHS. But to send the traffic to this NHS, NBMA address is required, na? But NBMA address is not there. NBMA address is not there. Right? So what we need, guys, now? We need now mapping, NHRP mapping. Earlier in phase 1, we had the tunnel destination, and that was the NBMA address. Correct? So now in phase 2, I have to run this command, interface tunnel 1 IP NHRP interface tunnel 1 IP NHRP map 192.168.10.12.1.1.1, right? Now see the hub router. So IP NHRP. Now it should have one entry. Okay. Interface tunnel 1 IP NHRP map 192.168.10.2 and 2.2.2.2.1. So IP NHRP. Fine. In the same way on R3, like on spoke 2 also, we have to map the NBMA address. Interface tunnel 1, say IP NHRP map 192.168.10.1 and 1.1.1.1. It will also send the registration request, and here you can just wait for some time. So run interface tunnel 1. I didn't map for spoke 2, so interface tunnel 1 and IP NHRP map 192.168.10.3 tunnel means side 2 spoke 2 and NBMA address is 3.3.3.1, and so IP NHRP. Again, these sites can now communicate with each other, right? Like ping 192.168.10.2. See, I am able to ping. That means I can ping 20.1.1.1 and source 10.1.1.1. Now the most interesting thing is how these two sites are going to communicate with each other. How these two sites are going to communicate with each other. So see, guys, so IP route static. Route is there for the remote side, like for spoke 2, 30 subnet is there. And next hop IP address is 192.168.10.1. 192.168.10.1. What will happen? Once I will ping to this IP 30.1.1.1, it will forward traffic to 192.168.10.1, means to hub router. At the same time, it will send one more message, that is NHRP resolution request message. It will ask for the NBMA address of remote tunnel site 2 spoke 2. So IP NHRP, here we have the mapping of NBMA address of hub router. See, trace route 30.1.1.1 and source 20.1.1.1. Guys, traffic is, wait, traffic is going to hub router, and then hub router will forward it to spoke 2, means router number 3. But see the next packet. Done. Now show IP NHRP and show IP route static. Numeric. Still traffic is going via hub router. The reason is, guys, configuration, static route configuration. So IP route static. We have manually configured this next hop IP address for this network. So if you will configure like dynamic routing protocol, or if I will change the next hop IP address here, now I can configure next hop IP address 192.168.10.3 directly the remote IP address of spoke 2. But router 2 need what? NBMA address of 192.168.10.2. So it will send one NHRP resolution request message to router number 1, and router number 1 will send NBMA address of 192.168.10.2. See what I can do here. I can say do so run section IP route, and let me remove this route. And then I am saying IP route, same network, but I am going to change the next hop 10.3. Done. See, show IP route or show IP route static. Next hop is for 30 subnet, next hop is 10.3, but show IP NHRP, but the NVMe address is not available for this IP, right? So for the first packet 30.1.1.1 and source 20.1.1.1 numeric, first packet goes via headquarter, but see the second packet is going directly, right? Second packet is going directly and so IP NHRP. Now guys, this router have NBMA address of spoke 2 as well. So this is what? One tunnel between spoke 1 and spoke 2. Also we have tunnel now. They can communicate directly via internet. Yes or no? Yes, sorry guys. अभी क्लास में होगा, क्लास के बाद फोन कर लेना सुबह को. Yes, sorry guys. Okay. So now these two sites can communicate directly with each other. So in DMVPN phase 2, first packet between the branch offices will goes via headquarter via hub router, right? But after that all communication will happen directly through the WAN circuit. In the same way on router number 3 also we can change the next hop IP address, IP route. Actually we are running a static route, that's why we need to change the next hop IP address, because in the static route we are defining the next hop IP address, correct? Or either we can use exit interface. I can use exit interface. Right. So if we are running the static route, if we have configured the static route with hub router next hop IP address, then definitely it will forward all traffic via hub router only. So we will be not using a static route here. Definitely we will be running any routing protocol. Even all routing protocol will work fine on these tunnel interfaces, right, over the DMVPN. and no to this. I'm saying no. Tell me which routing protocol you want to configure here. Router, OSPF, or you can configure EAGRP. Okay. Router EAGRPS number 10, no auto summary, network 192.168.10.0. It will enable EAGRP on interface, then network 10.1.1.0. Right? Do so. History, I am going to paste the same command on rest routers. Sorry, network command is going to be different. One network command. Network 20.1.1.0 and on spoke 3. Network 30.1.1.0. So IP EAGRP neighbor. Why we don't have neighborship? Multicast. Correct? So guys, I need to run command interface tunnel 1 IP NHRP map multicast to yes to unicast. See, again I have two options here. Either I can define the NVMe address or I can say what? Dynamic. If I will say dynamic, then what will happen? It will check the NHRP table, and in the NHRP table it will find the NVMe address. Do so IP NHRP. The NVMe address is there, right? So it will automatically convert multicast into these two IP address. Right? So IP NHRP map multicast and then 2.2.2.1 and 3.3.3.1. So IP EAGRP neighbor. So IP EAGRP interface. Done. Now we have neighborship. So IP EAGRP neighbor. So IP EAGRP neighbor. Here it's not showing. The reason is here also I need to map the multicast. IP NHRP map multicast and 1.1.1.1 and 3.3.3.1. Now so IP EAGRP neighbor. Done. So IP route EAGRP, you can see I am learning this subnet 10.1.1.0. Then on R3, so IP EAGRP neighbor, here you can see Q count is 1. That means there is error in EAGRP. The reason? Multicast mapping interface tunnel 1 IP NHRP map multicast and 1.1.1.1 and 2.2.2.1. Done. So IP EAGRP neighbor. So see, we have EAGRP neighborship with both the routers, with hub router as well and with spoke one as well. And so IP route EAGRP. Now for 20 subnet, next hop IP address is router 2. Router 2 tunnel IP address, and for 10 router 1 hub router. That means two spoke sites are going to communicate directly, right? EAGRP. I'm running EAGRP. You can run any routing protocol. No, see, brother, in the last class we had what? This tunnel here, right? Now we have tunnel here as well. So earlier in the next class, the spoke one was advertising this to headquarter, to hub router, and hub was not advertising it to R2. This time, hub one, sorry, spoke one is directly advertising it to hub also and spoke two also. Right. So trace route 30.1.1.1, source 20.1.1.1. Leave we can try from here. Trace route 20.1.1.1, source 30.1.1.1, and traffic is going directly, guys. Now let me do one thing. Let me don the tunnel interface once and then run NuSet again. Interface tunnel. तो टाइम लगे छे वहाँ वाला भेज देने रहे पुरने भेज देने रहे तो अपना फोन को कॉल ये यार कल के भेजता हूँ टनल वन shut down R3 also interface tunnel 1 and say shut down. Then guys I am going to run NoSet again. NoSet and here also say NoSet and so IP NHRP. See in the NHRP table again this is the static entry. Wait. So run interface tunnel 1. I think I have mapped all the IPR. No, because of the mapping. Clear IP NHRP. Correct. And clear IP NHRP and so IP NHRP. So IP EAGRP neighbor and so IP route EAGRP. We are learning directly. So we can do one thing here. I can say I can remove the static mapping from the tunnel interface tunnel 1 say no IP NHRP map and to map multicast to 3.3.3.1 do so run interface tunnel 1 here I am saying now dynamic mapping. I'm going to configure dynamic mapping. NHS IP address that is this one is the for hub router. I should not remove the done IP NHRP map multicast and then I am saying what dynamic and guys IP NHRP I am going to configure one mapping for the hub map 192.168.10.1 to 1.1.1.1. So run interface tunnel 1. See what will happen now. It will map multicast packet dynamically from the NHRP table. So show IP NHRP, and in the NHRP spoke 1 we have this entry as well. So clear IP NHRP. Yeah, I am going to remove the static mapping from R3 also. Interface tunnel 1 and say do so run interface tunnel 1 and say no to the static mapping. Do so run interface tunnel 1 and no to this, no to this, and no to NHS. This one is fine. Clear IP NHRP and so IP NHRP. Yes, see we have now only one mapping here in the NHRP table. Even on the spoke one also you can verify. So IP NHRP, we have only one mapping, clear IP NHRP, done. And so IP EIGRP neighbor. So IP route EIGRP, clear IP EIGRP, and then we can say process 10, I think neighbor, and let me use the neighbor IP address, done. So IP EIGRP neighbor. Actually I am trying to show you something here. Yeah, now q count is 1 for this neighbor, for both neighbor q count is 1. What happens? So IP NHRP mapping, clear IP NHRP. So IP NHRP, incomplete, and this one is the static. Why it's happening? So IP NHRP, clear IP NHRP. Still there is some misconfiguration. Router 3 is sending registration message. So run interface tunnel 1. Okay, because of this command, guys, this command is still there. Copy and interface tunnel 1 and say no to this command. Done. Now see clear IP NHRP and so IP NHRP. We have one mapping here which is the static mapping, and for static mapping you can see never expire, it will not expire. For the dynamic mapping there will be timer. After a specific time it will remove the entry. In the same way on this router on a spoke 1, so IP NHRP. So let me clear the NHRP table. So I clear IP NHRP and now so IP NHRP. Done. Static entry. We have only a static entry on both the spoke. Now so IP route EIGRP. See, I am not learning any prefix here on router number 2. On router number 1, so IP route EIGRP. We don't have any routes here. So IP EIGRP neighbor. My q count is 1 here. So run interface tunnel 1. Yeah, I have already told you, if you don't have a idea about the routing, don't worry. We'll discuss about the routing, right? And don't worry if you are not getting the things, bro. Okay, just do one thing, just leave the class, today class. Okay, at the end you will get these all. So here interface tunnel 1, and do so run interface tunnel 1. No, here mapping is not required. The reason, we have already configured the NHS on the client side, so they will register their self. Clear IP NHRP, and so IP NHRP done. Now I am expecting the correct output. Clear IP NHRP, and on spoke 2, spoke 1, clear IP NHRP. So IP NHRP. See, we have one static entry here. We have one static entry here. So IP NHRP. And on the hub router, we should have NVMe address of both sides. So IP NHRP. But there is no any entry. That means these routers have not registered their self. So what we can do? We can shut down the tunnel interface and then we can up the tunnel interface again. So interface tunnel 1 says shut down, and then no, shut down again. Done. Router 2 means spoke 1 have registered their self. Now I am going to up R3, again says shut down, and no, shut down. Now R3 means spoke 2 will also register their self. Wait. Okay, on router number 2, interface tunnel 1 and shut down, then no, shut down. Done, guys. Both router have, see, in the spoke 2, both router have registered their self on the hub router. Now we are running EIGRP routing protocol here on the tunnel. So IP EIGRP neighbor. We have neighborship with hub router. Like spoke routers have EIGRP neighborship with spoke router, but the queue count over is 1. Why queue count is 1? Anyone have idea? No, if you don't have the idea about the EIGRP protocol, don't worry, leave it for you. So if anyone have idea about the EIGRP protocol, guys, tell me why E count is 1 here. Like Behjat, Jyoti, you guys. This is, bro, one error in EIGRP. Whenever router will generate the query is a message of EIGRP, right? We'll learn it in the routing. Soon we will start the routing. Maybe, from the next week, we will be talking about the routing only. Now, so IP EIGRP neighbor queue count is 1 here. The tunnel interface SSRTT RAM, this one, hold on time, this one. So run interface tunnel. Actually this command is not working here. The dynamic mapping, multicast dynamic mapping is not working properly here, right? How you can check it? You can capture the link to find it. You will see it is still sending message on multicast address. This is the reason why we are getting this error. This is just because of simulation, guys. Here the dynamic mapping is not working. See, here on the hub router we have configured it statically, but on the spoke we have configured the dynamically, but dynamically is not working. See what will happen in the phase 2. All the spoke routers are going to register their cell phone hub router, right? Hub router will have NBMA address of all the spoke sites, right? So whenever like a spoke 2 a spoke want to communicate with each other, let's say 20 subnet want to communicate with 30 subnet, so 20, like on router number 2 we will have 30 subnet via hub router, right? So it will send first packet to the hub router, and it will see the next hop for the 30 subnet is 192.168.10.3, this IP address, right? But I am getting this prefix from the hub router. So router 2 means spoke 1 will send one resolution request message, means tell me the NBMA address of 192.168.10.3, and then in the response router 1 is going to send the NBMA address. This is how router 2 will get NBMA address of spoke 2, and spoke 2 will get NBMA address of spoke 1. Once these two spoke side will have the NVMe address of each other, they will form the tunnel here, and they will start communicating directly. Because let's suppose router 2 have this subnet 30.1.1.0/24 in their routing table, and next hop IP address is 192.168.10.3. So if router 2 have the NVMe address of 10.3, then it can forward traffic directly. If router 3 don't have NVMe address of 10.3, then definitely it will send to hub router. This is a concept of phase 2. In phase 2, all sites can communicate directly with each other. But the issue in phase 2 is, guys, like we cannot configure the summarization. We cannot configure quality of service. So DMVPN phase 2 is good for the a small organization, right? But it is not good for the large companies, for the large organizations, where you need to configure summarization, where you need to configure quality of service. You can say DMVPN phase 2 is not scalable with routing. Not scalable with routing. That's why we come up with DMVPN phase 2. Try to understand the scenario. Let's say here I have one more subnet, that is 10.1.2.0/24, and I want to summarize these two subnets. So my summary address is, let's say, 10.1.0.0/24, right? And then it will advertise to spoke 1 and spoke 2. Spoke 1 and spoke 2 will get only summary address. In the same way, guys, if here also I have one subnet 24, and here I am advertising summary address, then router 3 spoke 2 will advertise that summary address to router 1, and router 1 will advertise that summary address to router number 2, means spoke 2, with their exit interface. Means next hop IP address will be the hub router. So for summary routes, again communication will happen via hub router only. For all the individual prefixes, these two sites can communicate with each other. But when we will perform the quality of service on the headquarter, on the hub router, right? That time branch offices cannot utilize that directly. They have to utilize via headquarter. Like you can understand like this. Let's suppose a spoke 1 is advertising 10,000 prefixes to the hub router, right? And on hub router have capability to handle 10,000 prefixes. So this router can install 10,000 prefixes in their routing table. But let's suppose this router is the normal router, guys, cannot handle 10,000 prefixes. So what you will do, you will perform summarization here. You will summarize these 10,000 prefixes, and then you will advertise it to hub router. So if you are performing summarization on the hub router, then what will happen? Hub router will share their own next hop IP address. Now if router 3 want to reach in these 1000 prefixes, they will reach via hub router only. So in DMVPN phase 2, we cannot perform summarization on this hub router. If we will perform the summarization, then these two sides cannot communicate directly. Getting my point? So you can say in DMVPN phase 2, we cannot perform summarization on the hub router. We cannot configure quality of service on the hub router. So that's why it is not scalable for large organization. It is suitable for a small company. Even DMVPN phase 1 is not suitable for a small company, because in DMVPN phase 1 all the communication will happen via hub router. But here in DMVPN phase 2 all the sites can communicate directly, but we cannot perform the summarization, we cannot perform the quality of service. Let's say out of the 10,000 prefixes, I want to prioritize one subnet. We have one critical subnet, right? So we'll perform quality of service, will configure quality of service on router number 1. Then all the spoke sites will start utilizing that via hub router only. 1 minute, guys. And difference between DMVPN phase 2 and phase 3 is, in phase 3 we are going to add one more command. That's it. We'll only add one extra command in DMVPN phase 3. To understand DMVPN phase 3, you have to understand one thing, like the ICMP redirect message. Anyone have idea about redirect message, guys, in ICMP? Anyone have idea about the redirect message? Redirect message. Suboptimal path. Let me give you one example. Let's say I have a scenario like this. How can I design the topology? Let's say router 1, router 2. Router 1, router 2. Both routers are connected with one, let's say, switch. Like this. Right? Here I have one PC. Okay, it will work. Fine. R1, I2, Here IP address of this PC is, let's say, 10.1.1.10. IP address of router 1 is 10.1. IP address of router 2 is 10.2. 10.2. Guys, router 2 is, let's say, connected with internet. Yeah, now I can make you understand the indirect message, ICMP indirect message. Router 2 is connected with internet. On the internet we have one server, that is 8.8.8, right? On PC we have to define the default gateway IP address. Let's say here I have defined default gateway what, 10.1.1.1, 10.1.1.1. Now from the PC, if I am pinging 8.8.8, what will happen? Ping 8.8.8.8. PC will generate ICMP request message. It will forward to router 1. Router 1 will forward it to router 2, and router 2 will forward it to internet. Correct? You have to configure one default route here. On router number 1, we will configure 0.0.0/0, and the next hop IP address is 10.1.1.2. Right? In this scenario, you know what will happen. When PC1 will generate ICMP packet, in the ICMP packet source IP is 10.1.1.10, destination IP 8.8.8.8. Source MAC will be the MAC address of PC, default destination MAC will be the MAC address of router 1. It will forward to hub, hub will forward to router, or you can say this is switch or hub, anything, doesn't matter. Now router 1 will compare destination with their routing table, and then it will forward traffic from their same interface, right? So what router 1 will think, oh, I am receiving the traffic on same interface and I am forwarding it from the same interface. That means someone is using suboptimal path, bad path. Someone is using bad path. They should directly forward traffic to 10.2. Right? When R1 will receive the ICMP packet, it will compare destination IP address with their routing table, and after that it will get to know I need to route this packet from the same interface, from the receiving interface. You can say whenever router receive traffic on the interface and it find that from the same interface it has to send the traffic, the exit interface is same. In that case, router send one ICMP redirect message to the user. ICMP redirect message to the user, just to inform that brother, you are using suboptimal path, and it will tell to user that whenever you want to reach to 8.8.8, please forward traffic to 10.2, not to me. It will automatically generate redirect message, ICMP redirect message. This is a concept, right? One concept. You can Google it after the class, right? So same concept is applied, guys, in DMVPN phase 3. This is a concept of ICMP, right? Whenever R1 will receive the ICMP packet on this interface, and it will be forwarding from the same interface, it will exit the traffic from the same interface. R1 will think I have received a traffic on the interface and I need to forward it from the same interface. It means PC is using suboptimal path. Suboptimal path means not optimal path, right? So R1 will send a redirect message to the PC. With the help of that message, redirect message, it is telling that your next time you will forward traffic to 10.2, not to me. So in DMVPN phase 3, what will happen? Let's say from router number 2, I was receiving these two subnet 1020.1.2.0 slash 24, and spoke 1 is advertising both subnet 20.1.1.0 slash 24 and 20.1.2.0 slash 24. From router number 1, we are summarizing is it into 20.1.0.0 slash 16. Then we are forwarding it to router number 3. Now router 3 will install it in their routing table 20.1.0.0 slash 16, and next hop IP address is hub router 192.168.10.1. When router 3 will forward first packet to router number 1, router 1 will receive it on same interface, on the tunnel interface, and it will be forwarding from the same interface. So router 1 will send one redirect message. The only thing is we need to enable the redirect. By default, you can see on R1, so run interface tunnel 1. Redirect is, guys, no IP redirect is enabled. So we need to run IP redirect command. That's it. This is the only difference between DMVPN phase 2 and DMVPN phase 3. Rest all things are exactly same. Got it? In DMVPN phase 2 also, all sites can communicate directly. In phase 3 also, all sites can communicate directly, but in DMVPN phase 2, redirect feature is disabled. If we will enable that feature, then we are saying it is DMVPN phase 3, right? So simply I need to add one command here on the tunnel interface tunnel 1, IP NHRP redirect. It's giving warning. IP NHRP redirect failed to initialize. Do so, run interface tunnel. Command is applied over here. Both command is showing, right? This is, guys, issue of this software only. IP NHRP network ID 1, IP NHRP no interface tunnel 1. Let me configure it again. No interface tunnel 1, and then interface tunnel 1, IP address 192.168.10.1, then tunnel GRE tunnel mode GRE multi-point tunnel source fast Ethernet 0/0, then IP NHRP map multicast, I can say dynamic, and I think dynamic keyboard is also not working right here in the simulation. Dynamic keyboard is not working. Then IP NHRP, I have configured the network ID 1 and IP NHRP redirect. You can try it in GNS3. Definitely redirect command will work. Even we are not able to run this command right on any interface. See, if I am creating interface tunnel 50 and I am saying IP NHRP redirect. So this command is not working in EVNG, or maybe it is not supported on this particular router. We had one topology in GNS. We can try there. Yeah, I think this command is not working on 72003 series router, and this one is I think 72003 router only. So IP version, yes, 7200 router, it will not work. Redirect command, we cannot configure DMVPN phase 3 on 7200 routers, guys. So definitely we have to open GNS3 for this. And brother Harsh, don't worry about the commands, right? Definitely you have to use Google only to find the command, or you can practice. You can practice. See, mm, see, I don't have anything, right? Like to check the commands and whatever command I am running there. This is just my practice, right? Because I am running this same commands multiple time, and I'm configuring the EAGRP, OSPF, the VPN, right? So when you will start performing labs, right, automatically you will get the commands, right? So in the starting, definitely you have to use Google book to find the commands or to the some the concept. But once you will start involving yourself in these things, everything will start becoming automatic, right? Because whatever I am teaching you, everything is here only, right? From here only I am teaching you. Even you can see I never use the PPT to teach people. I'm not using PPT as well, right? So directly I'm writing on the board. Even you will not find like this type of this example anywhere, not on the internet, not in the book. Right now I have created this scenario that like this I can try to teach you. I can try to make you understand, right? So definitely bro, in the starting you have to find the commands, lot of things from the Google. So the solution is try to perform More lab as much as possible. DM VPN, this was. Yeah. Mm-hmm. Correct. Direct tunnel means both have NBMA address. Summarization means, see still, see still in phase 2, brother. Just wait, I am explaining it. 1 minute. No, I didn't get your second question. Please explain again. Correct. Like IP NHRP map command. Mapping command, brother. Right? Correct. So like when you will add the like new branch, then every time you have to configure each branch routers. If you are going to map manually, then you have to run, you have to modify the configuration every time while adding the branch offices. I think this was your question, right? No, that is then the GRE tunnel. Then there will be tunnel directly spoke to spoke. So they will communicate directly. But in the spoke 2, you can see the first communication is happening via hub router only. Right? Means in the spoke 2, you will not have EIGRP neighborship here. You will have EIGRP neighborship via hub router. Means these hub means spoke sites are going to exchange routes via hub router, but they will communicate directly. Getting my point? Route exchange will happen via hub router only. We will not have here EIGRP neighborship. Otherwise, just think if we have thousand number of branch offices, then all the router will have thousand number of EIGRP neighborship. Like there will be full miss EIGRP topology. Every spoke routers are going to form neighborship with all branch offices. So we'll form the EIGRP neighborship between hub and spoke only, and They will communicate directly in phase 2 also, in phase 3 also. Only communication is going to be happen directly, not the route exchange. Route exchange will happen via headquarter only. Like between three sites, how many AGRP adjacency is there? 2. If you are forming here also AGRP neighborship, then total number of AGRP adjacency is 3. Means now this router is going to maintain 2 neighborship. This router is also going to maintain 2 neighbor. This router is also going to maintain 2 neighbor. Total number of neighborship is 6. Right? But if a spoke is forming neighborship with hub only, then we have only 2 neighborship. Yeah. Yes. Correct. Hub on, yes, on hub we have 2. So if we have 100 number of branches, hub router will only have 100 neighbors. All the spoke routers will have only one neighbor. So we will invest lots of money on the hub router, like we'll purchase the high configuration router here and we'll put the normal configuration router on sides. Correct, correct. Right. So here you can try to run redirect command. Interface F0 slash interface tunnel 1 do so IP interface brief. Interface F0 slash 0 no set and IP address 11.1.1.1 exit interface tunnel 1 IP address 192.168.10.1.255.255.255.0 IP NHRP network ID 1, and here I can run IP NHRP redirect command. NHRP redirect. See here this command is working. Right, I think this is 3.5 series router do so version. Yes, 3527 series routers. So tunnel mode GRE multi-point tunnel source fast ethernet 0 slash 0 do so run interface tunnel 1. So I have configured the IP, I have configured the NHRP protocol, I have configured the tunnel source, I have configured the tunnel mode. What extra configuration is required here? Leave authentication. No IP redirect for now. IP NHRP map multicast, I'm saying dynamic. So first I'm going to configure phase 2 interface loopback 1 and IP address 10.1.1.1 255.255.255.0 and one default route. IP route 0.0.0 0.0.0 and 11.1.1.2 I think. Interface F0 slash 0 no cert IP address 22.1.1.1 255.255.255.252. There is one still misconfiguration here, I think. Interface F0/0 IP address 11.1.1.1 255.255.252. No set exit IP route 0.0.0 and 22.1.1.2 and do ping 11.1.1.1. Ping is not working. So IP route default route is yes. So IP interface brief. The interface is also up. Ping 11.1.1.2 and ping is working. This ping is also working. Now interface tunnel 1 IP address 192.168.10.2 255.255.255.0 tunnel mode. Tunnel mode will be what? GRE multi-point in phase 2. Then tunnel source fast Ethernet 0/0 and what next? IP NHRP protocol, IP NHRP network ID 1 and IP NHRP NHS 192.168.10.1. So on the hub router, so IP NHRP, there is nothing. IP do so IP route, default route is there, and do ping 11.1.1.1 and do ping 192.168.10.1. This ping is not working. Mapping. Do so run interface tunnel 1. So mode is fine, the NHS IP address is fine. The only thing is mapping. IP NHRP map 192.168.10.1 and the NVMe address 11.1.1.1. Right? See, if you will run this command for the spoke 2 also, then it will form neighborship. Right? Now guys, can I ping the remote tunnel? Still ping is not working. What was the issue? NHS map the IP address, NHS IP address for 11.1.1.1, correct. NHRP protocol, no, redirect. Everything looks fine here. Yeah, mapping is also there, 192.168.10.2. So it should work, ping should work, and ping is working now. Interface F0/0 no set IP address 33.1.1.1 255.255.255.252 IP route 0.0.0 0.0.0 and 33.1.1.2 do ping 11.1.1.1 working. Interface tunnel 1 IP address 192.168.10.2 255.255.255.0 tunnel mode GRE multi-point IP NHRP network ID 1 IP NHRP map 192.168.10.1 to 11.1.1.1 and IP NHRP NHS is 192.168.10.1. Then do so IP route, do so run interface tunnel 1. Why tunnel is down? Tunnel source. So until and unless you will not define tunnel source, tunnel interface will be down only. Done, and do ping 192.168.10.1 and this ping will work. Just wait for some time. Okay. Mapping is correct. So IP NHRP, there is only one mapping, NHS IP 192.168.10.2. It's correct. Shutdown and no shutdown. What happened here? Do so IP interface brief. Try interface is up. Sorry, IP is incorrect, right? On the tunnel interface, IP and is 192.168.10.3 255.255.255.0. Now so IP NHRP, wait for some time. Shut down. No shut down. Done. Both routers have registered themselves here. And guys, to see the message, you can even capture this link once. Let me show you. Yes, on the spoke one, I am going to set the port. Done, and say no set again. So see the NHRP registration request message, right? So in the NHRP registration request message, NHRP mandatory part, see it is sending their NVMe address and their IP address to whom? To the hub router, right? And is there any respond message? Yes, this one is the respond message. No registration reply message. So in the response message, guys, we have exactly same information, right? This is for the acknowledgement only, the reply message, right? That NHS is saying, hub router is saying that I got your information. Like this, both router will share the information. Now here, I am going to run one routing protocol. Let me say a router EAGRP, or it will be better to run OSPF here. Interface range tunnel 1 and loopback 1. Mm, mm, mm. Okay, then router EAGRP as number 10 and network 10.1.1.0 no auto summary and network 192.168.10.0. Do so history. We cannot copy and paste this command. Okay, not this one. Network 30.1.1.0 and I am going to create one loopback here, interface loopback 1 and IP address 30.1.1.1.255.255.255.0. Is someone writing? Good. Done. Then on the hub router config T router EAGRP is number 10 network 192.168.10.0 and network 10.1.1.0 say no auto summary. Router EAGRP is number 10 network 192.168.10.0 and network 20.1.1.0 and no auto summary exit interface loopback 1 IP address 20.1.1.1 255.255.255.0. See, everything is working fine. So IP EAGRP neighbor. The problem is so IP EAGRP neighbor. What is the problem, guys? Multicast mapping. So here on the hub router interface tunnel 1 I'm saying IP NHRP map multicast. Here I can say dynamic keyword. Let me check dynamic keyword is working or not. So IP EAGRP neighbor. So IP EAGRP neighbor still queue count is 2. So IP EAGRP neighbor and so IP NHRP. So IP NHRP there is one mapping. So interface tunnel 1 IP NHRP map multicast 11.1.1. Copy this command and let me paste same command over here as well. Interface tunnel 1 done. And so IP EAGRP neighbor. Now you can see we have soon Q count will become 0. Yes, now you can see Q count is 0 and so IP route EAGRP. So we have 10 subnet here. Now the again why router hub router is not advertising 20 subnet or the 30 subnet because of split horizon. This is the part of routing protocol, EAGRP routing protocol. Don't worry. Interface tunnel 1 say no IP split horizon, no IP split horizon for EAGRP as number 10. Now so IP route EAGRP. Got it? And so IP route EAGRP. Now guys, try to understand the issue. What I am going to do here on spoke 1, I am going to create some more loopback. Loopback 2 IP address 20.1.2.1.255.255.255.0 interface loopback 3 and IP address 20.1.3.0. Done. Then router EAGRP as number 10 and I am going to run network 20.1.0.0 command. This command will advertise both interface. So IP EAGRP interface, you can see now EAGRP is enabled on all the loopbacks interface. So spoke 2. So IP route EIGRP. Guys, if you are not able to understand the routing concept, don't worry. Again, I am saying, right? So here you can see we have all these individual subnet, and the next hop is hub router, right? So first packet will go via hub router, but second packet will go via ISP directly, right? So from spoke 2, I am going to trace route 20.1.1.1 and say source 30.1.1.1. First packet is going via hub router, and second packet will go directly. Second packet will go directly. But why it's not going directly, guys? So IP NHRP. There is no NBMA address available for the tunnel. So this time this hub router should send one resolution response message. See, there is one caption, and from the spoke 1, so IP route EIGRP, we have 30 subnet, and next hop IP address is 10.2. So adjacency 30.1.1.1. Prefix note in the SAP table. Fine. Just a minute, just a minute, just a minute. There is still some error. Still second packet. Interface tunnel 1, no IP, next hop self for EIGRPS number. Ten. Yes, now second packet is going directly. This is what? Phase 2. And if I will down the tunnel interface tunnel 1, say shutdown, because do so IP NHRP. Because guys, see here we have the NBMA address of 10.3. So this time router can forward traffic directly, right, to 30 network through internet. NBMA address is available. This is the NBMA address, right? Again, I am saying shut down to this tunnel interface. Once tunnel interface will goes down, it will erase the NHRP table, and again when interface will come up, it will form the EIGRP neighborship with hub router, and it will learn the network information. So IP route EIGRP, it have learned the 30 subnet, and again next hop is 10.3, means it will forward traffic directly, but the issue is, so IP NHRP. This is the actual issue in phase 2. The next hop IP address is direct remote site IP address, not the hub IP address, but NBMA address is not available. So that's why router will first send request to hub router. See in the capturing. In the capturing, when I am going to trace route, again trace route 30.1.1.1, going traffic via hub router, but this time it have sent one resolution request message. And in the resolution request message, it is asking for the NBMA address of 10.1, sorry, 192.168.10.3, correct? And in the response, hub router will send what? NBMA address. See the resolution message. In the resolution message, it is sending what, guys? NBMA address. Somewhere you will find the NBMA address here. NBMA address. Who is sending? Directly router 3. Actually, hub router is not going to send the resolution request message. Hub router will relay that resolution request message to spoke to router number 3, and router 3 will generate what? Reply directly. Two things will happen here. Router 2 will get NBMA address of spoke 1, and it will share their NBMA address to spoke 2. Now both router have NBMA address, both branch office routers have their NBMA address, so now they can communicate directly. They can communicate directly. But the issue with phase 2 is clear, guys, now to everyone. Phase 2, in phase 2, see, the next packet is going directly, because this time it have the NBMA address, right? So in phase 2, you will see the next hop is the IP address of spoke, but NBMA address is not available. That's why first packet will go via hub router. And interviewer will also ask you same question, like in phase 2, why first packet will go via hub router? The reason, next hop IP address will be the IP address of remote side, the branch office, right? But NVMe address will be not there. Now the issue is, see, on the hub router, so IP route EIGRP, I am learning these 20 subnets from router number 1, from spoke 1, and I want to perform summarization. I want to advertise summary route to this router, to router number 2. So what I will do, guys, I can run command interface tunnel 1 and IP for now on spoke 2. So IP route EIGRP, it is learning all individual prefixes. Now IP summary address for EIGRP as number 10, and summary address is 20.1.0.0, let's say 255.255.0.0. Done. I have advertised the summary address, perform the summarization. Now see spoke 2 routing table. It is receiving the summary address, but now you don't have any option to change this next hop. Yes or no? Now we cannot change this next hop. Every time now spoke to this router will ping, will forward traffic in this subnet via hub router only. So that's why what we want, guys, redirect concept, that whenever hub router will receive traffic for 20 on this interface, it will forward to router number 1. So it is using suboptimal path, so it should inform to router number 3 that, bro, you are using suboptimal path. Do one thing, whenever you are going to forward traffic in 20 network, next time please forward it to directly spoke 1. That's why here we need to configure what? Redirect command. This is the only difference in phase 2 and phase 3. Hope it is clear now. Yeah. Correct. Correct. Right. And brother, one had asked about the EIGRP neighborship between spoke to spoke, right? So IP EIGRP neighbor. See, we don't have any EIGRP neighborship here between spoke 1 and spoke 2. Yeah. Spoke. Yes, in 3 also. In 3, see, now if I will trace route 20.1.1.1 and source uh, from spoke to, yes, 30.1.1.1, traffic is going via hub router only, right? Every time traffic will go via hub router. So to resolve this issue, we come up with DMVPN phase 3. That's it. Correct. Correct. So on the hub, simply I can say, and see brother, if we will form the EIGRP neighborship between spoke to spoke, then CPU utilization is going to be very high, right? Because here you are able to see only 2 sides. But in real time, just assume if you have 100 number of branches, if you have 1000 number of branches, just imagine the companies like Google who have 5,000, 10,000 data center across the globe, right? So they cannot form like this amount of neighborship. Correct. So on the hub router, to enable phase 3, I'm going to run command interface tunnel 1 and IP redirect. And on spoke, we run the shortcut command interface tunnel 1 IP NHRP shortcut. And now if you will trace again interface tunnel 1 IP NHRP shortcut. See, if I am tracing again to 20.1.1.1 and source 30.1.1.1, traffic is going via hub, but this time hub router, next time hub router will send one redirect message. So you can see traffic is going directly now. This is the only benefit of using phase 3. Otherwise, rest everything is exactly same in phase 2 and phase 3. The difference between phase 1 and phase 2 is in phase 1, all the branch offices are going to communicate via hub router. In phase 2, all the branch offices can communicate directly, but we cannot perform the summarization, we cannot configure the quality of service. Same thing will happen with quality of service also. Like if I am applying the quality of service on hub router, right, it will start applying that, it will start advertising that policies to branch offices with their own next hop IP address. So every time spoke routers will utilize that via hub router. But in phase 3, first packet on hub router will receive the first packet, it will get to know, no, it is using the suboptimal path. So let me inform him to send traffic directly. Correct? 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 The concept of redirect is, guys, whenever router is forwarding traffic from the receiving interface, it will get to know that someone is using optimal suboptimal path. So if redirect is enabled, then it will perform two things. First, see, when it will receive the first packet, it will forward that packet to spoke 1, and at the same time it will inform to spoke 1 as well. Right? That bro, you can communicate directly. Why you are sending traffic to me? No problem. From next time, take this next hop IP address, right? It will hub will get to know. See, I am forwarding traffic to 192.168.10.2, so it will send that next hop to router number 2 to spoke 2 to router number 3. That this is the next hop IP address. Next time, please forward traffic to this one, and spoke 2 will change the next hop. Now you can check the routing table here. So IP route. Next hop is still, guys, hub router, right? Now here you have to understand the SAF. Actually, routers are not using routing table to forward the traffic, right? This is the traditional WAN, traditional way to forwarding traffic. Nowadays it is using what? SAF. So in the it will update their SAF table. So IP SAF and 20.1.0.0. So adjacency 20.1.1.1 255.255.255 dot, not like this thing, 20.0.0 255.255.0.0. Yeah, lots of time you are asking about the MPLS, right? So what I told you, MPLS is one way to forward the traffic, like routing. SAF is also one way of forwarding. Like we have multiple types of forwarding, brother, like switching, routing, then Cisco Express forwarding, yes, FIV, then MPLS. These are what? Packet forwarding process, right? So switching is what? Forwarding traffic on the basis of MAC address. Routing is was forwarding traffic on the basis of IP address, 32 bits address. SAFE is what? Forwarding traffic on the basis of adjacency information. You will learn about the SAF in the MPLS, right? MPLS is forwarding traffic on the basis of label, right? So for each route it will add the label. So what we are trying, see, in the routing, router have to check 32 bits address to forward a packet. So we are reducing this size. We want that router should check very less information, and on the basis of that router can take forwarding decision. Yes, only exit interface. FIV is just a duplicate copy of RIB. Correct. Okay. So from the Monday, see, there are some students who have already covered the routing module, switching module, many modules. They need to learn a few more things. So we'll separate the batch, and guys, we will continue from the routing, right? So from the next class, means from the Monday, we will starting the routing. Before routing, it will be better to discuss some basic concepts of routing, like the packet flow, okay? And see, day by day we'll move to the deep into the routing. Okay, so hers, I know many people have no any idea about the routing, right? And they want to learn the routing first. After that, definitely they should learn the DMVPN and these things. So don't worry, guys. If you will feel that you are not good enough in DMVPN after the routing, will I will teach you again, right? These things. Before leaving you, I will make sure that you have knowledge about everything. Okay. Yeah, and Behzad, what we will do, we will conduct our classes on the weekend, where either we will start the wireless or we will start the security. The, from tomorrow, from this weekend. Yes, yes, same time. Yeah, yeah.